Okay, this is 2-74, and this is kind of part 2 of 2.1.8. So it says, in later courses you'll learn more about situations like part A and B in the preceding problem called inequalities. For now, to learn about x, assume that the left-hand expression and the right-hand expression are equal. The two expressions will be brought together on one mat to create an equation mat. So hopefully you'll get little copies of these in your class. You can make one if you don't have one. The double line down the center of an equation mat represents the word equals. It is a wall that separates the left-hand side of an equation from the right-hand side. So it says get your mat resource page. I guess you can get one at cpm.org, or you can just make your own like I did. And then it wants us to build this with the tiles and simplify. So I'm going to go through this and show you how to build it and simplify it. I'm pretty sure you already know how to build something. It wants an X tile. You'd think I would have all my tiles out and ready to go, huh? It wants an X tile, and let's see, it wants a blue X tile over here, and then it wants a couple negative ones and a positive one over here. I'll move it where you can see it better in a little bit here. So you can't see both places at the same time. And then we want some ones. So let's see. How many ones do we want? 1, 2, 3, 4, 5. We want 5 of them. So I hope that if you're watching this, I hope your book's with you, because I'm going to have to move this book where you can't see it anymore. Otherwise you won't be able to see my page. But on the bottom I see 2 red X's are going to go on the bottom left-hand corner, and a positive 1. And a positive 1. Okay, all I'm doing is I'm just building that picture right there. So a red X and a blue 1. Okay, so hopefully you can see that's positive region up here and the negative region down here. Okay, and do I have everything like the book does? I'm checking it to see if I do. 1, 2, 3, 4, 5. Did I count it all right? Yes, I did. Okay, so I'm just going to show you how I would solve this if this were my problem. Now remember, this now is an equal sign. Okay, now it turns out that my favorite trick of flipping these up like this, I like to flip them all up first like this. I don't know if that's your favorite trick. That's my favorite trick. I like to flip them all up, and we're allowed to, as long as we flip them upside down when we put them in the positive area, and then we can get rid of our 0 pairs. See, those make a 0 pair. Here's another 0 pair. And then we're allowed to do some other incredibly cool stuff. We're actually allowed to flip them over the top of the equal sign. So just like we could flip them up from the negative region to the positive region, we can flip them over the equal sign, but I don't know if your teacher's going to like that. I think your teacher might like to see this. I can add, I'm not going to flip them right now, because I think that's kind of a shortcut that you might not want to be taking yet. What I'm going to do is I'm allowed, if this is like a balance beam, you know, like an equal sign, it's like a scale, so you can go heavier or lighter. If I add the same amount to each side, that won't hurt anything. So I'm going to just, not randomly, but I'm going to grab these 2 red bars. I wonder why I'm doing this. Why would I do that? Why would I add a red one on each side? You're probably raising your hand going, I know, because it made a 0 pair over here. Okay, so it made a 0 pair, and it made a 0 pair. Why would I want to do that? Because I want all these X bars on one side of the equal. This is the equal sign. I want all the X bars together on one side and all the ones on the other side. So in other words, I'd like to get those red ones to go away so that I could just have the X's on the left. I like the X's on the left and the ones on the right. Okay, how can I make these two red ones go away? Well, if I had some zero pairs to pair them up with, that would be great. So what I'm going to do, since I'm allowed to add the same amount to each side of the equal sign without upsetting the balance, I'm going to add 2 blue ones here and 2 blue ones here. Why did I do that? Well, because I'm allowed to add the same amount of weight to either side of the scale without tipping the scale. It's like a scale. Okay, and I did that on purpose because now I see that I made 0 pairs for myself, which I wanted to do. Now it turns out later on you're going to find out that you can just simply flip stuff over this equal sign, but I'm not sure if that's what they want you to do at this point. So we're just going to add stuff to make 0 pairs. So I would like, now what I'm going to do is I'm going to line up my X's. Like I'm going to kind of divvy out a 1 to each X, you know, like 1 for you, 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 1 for you. So it looks like there's, for each X, there's 3 ones. So guess what? X equals 3. 1X equals 3. 2X's equals 6, but each X equals 3. Each X is worth 3, and you can see that because there's an equal sign right here. And like I said, this, I don't know if this makes sense on the camera. This is like a balance. Here, let me draw a little balance scale. You can imagine that I loaded up these 2 bars onto the left-hand side of my scale. This is a scale, you know, those old-fashioned ones. And then I loaded up these 6 things over here, and since it's an equation mat, it says that they're equal, they're balanced right now. Okay, so if it's balancing out, and there's 2 of these and 6 of these, then each one of these must be worth 3. So X equals 3. So the answer is X equals 3. So basically we just solved an algebra problem using algebra tiles. Do I have more time? Yeah, I have a little bit more time. Let's see what else it says. Okay, so build this equation. So I'm on letter B now on 2-74. Build that equation. Then use your simplification skills. Okay, I didn't record my work on this last one, so I'm going to practice recording my work on this one. I need 2x minus 5 on the left-hand side. So here's 2x minus 5. We're going to do this a little faster. There's 2x minus 5 on the left. I'm just reading it right off of your book right here. 2x minus 5. And I need negative 1 plus 5x plus 2. Negative 1, 5x, okay, so this is negative 1 plus 5x plus 2. Now, yeah, there's other ways I could have built it. I could have put some of these down there or something if I wanted to, but I just decided to build it all in the top region. Yep, and that's all we have to do. So now we're going to just use our simplification skills. So this time I'm going to record what I do. I'll just record it down here, okay? I'm going to take this 0 pair right here and get rid of it. So now, that's all I'm going to do right now. So now I have 2x, minus 5 equals 5x plus 1. Now, I would like all the x's on one side and all the ones on the other side. It's actually easier for me to get the rest of the x's to come over here. You know what I mean? Because like if I wanted these all moved over there, that's a lot of people that have to move over there. So I'm going to actually make these guys go over there. How's that going to work? I'm going to add some red X's on each side of my scale. See, look, if I add these 2 red X's over here, and I'm allowed to as long as I add the same amount to this side. Watch. Adding red X's is like saying minus 2x. Okay, and then I minus 2x. And don't these 0 pairs go away? Yes, sir. Yes, ma'am. They go away. So there they go. And then there's, I just bring down my negative 5. And then 5x minus 2x, well, these 0 pair. Bye-bye. I did that on purpose. There's only 3 x's left, plus 1. Now, I got all my x's together on this side. I'd like all my 1's on this side. Who do I need to get rid of? Him. How do I get rid of him? I need something to make a 0 pair. So if I put a red one here, though, I have to put one here also. Okay, so I'm going to record what I did. I put a red one on the right-hand side. I put a red one on the left-hand side. That goes away. And then I've got, on this side, watch, after they go away, I've got 3x is equal to negative 6. And then guess what I can do? I'm almost done. I'm going to turn these sideways, and I'm going to divvy out all the 1's, like 1 for you, 1 for you, 1 for you. Oh, it's going to work. Good. 1 for you, 1 for you. Everybody gets 2. So each x gets negative 2. So in other words, I divided my negative 6 into 1, 2, 3 little piles. So I can say I divide it by 3, and then I can say x equals 1x equals negative 2. And isn't negative 6 divided by 3 negative 2? Okay, that is the end. Good luck. Have fun.